Hi, I'm Carly. In this video, we will explore together the detailed procedure for configuring digital signal modules of our EB80 system within the Siemens TIA Portal development environment. I will guide you step by step through the process in a simple and clear way. Stay with me to discover everything there is to know about this topic. The EB80 has different digital input and output modules. Modules with 8 digital inputs and modules with 16 digital inputs. Modules with 8 digital outputs, modules with 16 digital outputs, modules with 6 digital outputs with separate power supply, and modules with 16 digital inputs and outputs, also configurable as encoder channels. By double-clicking on the EB80 system within the hardware configuration, the device view window will open. From the hardware catalog on the right, we click on the Modules section, Digital Modules, where we can select the available modules mentioned earlier. For example, we insert a module with 8 digital inputs, a module with 8 digital outputs, and then in the Input-Output Modules section, add our new module with 16 digital inputs and outputs, also configurable. By selecting module S01, that is our module with 8 digital inputs, and clicking on Properties, the configuration screen is accessed. Within the Module Parameter section, the specific parameters of the module open. Polarity allows defining, for each input, whether the signal must be of PNP or NPN type. Activation state allows configuring each input as normally open, NO, or normally closed, NC. Signal extension time. It is possible to set a delay from 0 to 100 milliseconds. This function allows extending the duration of the input signal to ensure that even very short pulses are correctly detected by the PLC. Another configurable parameter is the input debounce time. This is a time filter, adjustable up to 20 milliseconds, which allows ignoring any signals shorter than the selected value. This function is useful to avoid detecting false signals caused by bouncing or electrical noise on the digital inputs. It is also possible to configure the parameters of the digital outputs. To do this, we select the Digital Output module, right-click and choose Properties, then access the Module Parameter section. Within this screen, we can configure polarity. For each output, it is possible to select the signal type, PNP or NPN. Activation state allows setting each output as normally open, NO, or normally closed, NC. Failsafe defines the behavior of the output in case of PROFINET communication loss or network error. 3 options are available for each output. Hold last state maintains the previous state. Output reset forces the output to turn off. Output set forces the output to turn on. These conditions are activated in case of PROFINET communication loss or in the presence of a communication error on the PROFINET network. Finally, for the 16-channel module configurable as input, output, or encoder channels, we proceed with the configuration as follows. Right-click on the module, select Properties, then access the Module Parameters section. The screen called I/O mask will open, from which it is possible to configure each individual channel as digital input, input, digital output, output, encoder channel, encoder 1, channel 1. This configuration can be performed independently for each channel of the module, allowing high flexibility according to the application. The activation state parameter can be configured for both inputs and outputs. The extension time parameter applies exclusively to inputs and is the same parameter previously mentioned for digital input modules. The debounce time parameter applies exclusively to inputs and is the same parameter previously mentioned for digital input modules. The failsafe parameter applies exclusively to outputs and is the same parameter previously mentioned for digital output modules. It is also possible to enable or disable the 2 encoder channels available on this module. After inserting our modules, we return to the network view, select our PLC, right-click, then choose Compile to start compiling the hardware configuration. At the end of the compilation, we right-click on the PLC again and select Load to download the hardware configuration to the device and execute the upload. Once the download is complete, to verify that our hardware configuration has been correctly downloaded, we click on Go Online. As we can see, the hardware configuration is completely green, so the download was successfully completed. By double-clicking on the device, it is possible to write and monitor the memory areas associated with it, to verify correct data exchange and the functioning of the application. Great job! I hope this guide has been useful and clear for you. Thank you for watching this video with me.